So we left off yesterday finishing with number 2. So we should be looking at the distance formula today. So if you don't know the distance formula, you should have used it in Algebra 1-2 last year. I make the assumption that you know the distance formula. If you don't, put it on a flashcard and learn it. You will use it throughout every math class you ever take. It's never going to go away. The distance formula is derived from Pythagoras' theorem, and so that's what they're showing you here. We can find the distance between 2 points by plotting the 2 points in a coordinate grid, creating a right triangle with a vertical and a horizontal leg for that right triangle. And you can visually count that vertical distance and count that horizontal distance. And we could throw that in Pythagoras' theorem right here. This is Pythagoras' theorem. You could find the distance that way. The 2 points that you're finding the distance of, they'll always be your hypotenuse. So this would always be side C in reference to Pythagoras' theorem. And the legs could be side A or B, it doesn't matter which is which. So you could do that. The problem is if you get big numbers that you're trying to find the distance between big ordered pairs like 20, comma, -5. I mean, who wants to plot those, make a right triangle, and use Pythagoras' theorem? So at some point you're going to have to use a distance formula. In higher level math, you have to use that distance formula. So they want you to do the following. Well, I don't really care about questions 17, 18, 19, but use a diagram above, draw a line from each triangle, side in column A to the corresponding side in column B. Quite honestly, y sub 2 minus y sub 1 could go to A or B. It doesn't matter. And same thing with x sub 2 minus x sub 1 could go to A or B. The legs, which are these right here, well, I guess it's a leg, singular. These together could be either one. But the distance, that definitely is C. So, if you look at question 3, segment SR has endpoints at -214 and 3, -1, and they have plotted those for you here and here. Then they've created the legs of that right triangle, and they have gone ahead and found the vertical distance. Vertical distance is your y distance, and so how far is it from 14 to -1? That's what they're trying to ask you here. This is a -1 right in there, by the way. How far is the distance from +14 to -1 on the number line? Distance is always positive, so it would be a +15, right? I see that if you add those, I know why you're coming up with a -15. But remember, your distance is positive. So I would look at it as a positive. I don't know why they're showing it with a negative. That's really, put absolute values around this. And then the horizontal distance from here to here is your x distance. Oh, is that from this ring? Okay.
Is distance always positive?
Distance is always positive, no matter how small we are. Don't let anybody tell you that you have a negative height. I've never been accused of having a negative height, but my best friend is like 5'2". She's tiny. All right. Cute though, really cute. All right. So we've got the distance here from your x values, because it's your horizontal distance from 3 here to -2. So on the distance line, the distance from 3 to -2 would be what? 5. And so this is 5. So again, make sure that there's absolute value signs around that. Because you should be taking a positive distance. And I wouldn't even be subtracting them, I'd just be counting, to be honest. And so then this is our C, our hypotenuse. It should always be the longest side of the right triangle. And so we could, over here, take 15 squared and add 5 squared and set that equal to C squared. What's 15 squared? Anybody know? 225 plus 5 squared is 25 equals C squared. 225 plus 25 is 250 equals c squared. And then to find c, can't I take the square root of both sides? Now technically we should do plus or minus the square root of 250, but we know that that distance is not going to be negative. So I'm going to break 250 into its prime factor so that we can take its square root. I know that 25 divides into 250, and it goes in there 10 times. And so then this is 5 and 5, and this is 2 and 5. So can't I pair up a pair of 5s? Bring that out in front. So that means that C is equal to 5 comes out in front of the radical, and I have a 2 and a 5 left over. So that means 2 times 5 is 10, goes underneath the radical. So that's using Pythagorean's theorem. Over here, they've used the distance formula. So for the distance formula, if you recall from algebra, it's just the difference of the x's, the difference of the y's. You square each one of those, add that together, and take the square root. Again, that was derived by solving this Pythagorean's theorem here for c. And so all they did was take the square root of both sides. So the distance of a and the distance of b represents that difference in x's and y's. So here we go. So this should be, and quite honestly, it doesn't matter if you put your y's first here and then your x's. It really doesn't matter if you do x of 1 minus x of 2. What's going to happen is one of you is going to get a positive value, one of you is going to get a negative value. They're going to be the same number, but when you square them, if I square 3 and negative 3, don't I get the same number? True or false? So it won't matter. But here we go. So this is x of 2. This is y sub 2. So they've gone ahead and put x of 1 in here, which is your negative 2. So they're calling this one up here x of 1, y sub 1, because that's what they chose to place there. It doesn't matter which is 0.1 and which is 0.2. And so that means that this must be x sub 2, and this must be y sub 2. So then we're going to put in for x sub 2, 3. And we're going to put in negative 1 for y sub 2. And you'll notice that they look, don't these look identical here? And don't these look like identical there? So I get 3 plus a positive 2, which gives us 5 squared. And we get negative 1 plus a negative 14, which gives us negative 15 squared. 5 squared is your 25, negative 15 squared is 225, so now we're looking like this. Square root of 250, and, well, they're giving a decimal equivalency. I would prefer that you put your answer in fully simplified form. So note to self, the answers are going to show a decimal answer. I want you to simplify the radical correctly. You can then check it on your calculator and give a decimal answer as well, that I want this answer also. Because when you take a test with me, that's the answer you're going to need to get. All right? So the book and I disagree on answers. And then they've just given you the reasonings why along the side. So then look at the last problem. It's a little hard to see this, but you've got the zip line cores here. Real hard to see, especially with this copy. On a zipline course, you're a harnessed cable that travels through the treetops. And you can see it goes on a line from A to B, to C, to D, to E, and then to F. So there's your pathway. You start at platform A and zip to each of the other platforms. How far do you travel from platform, so how far from platform D to platform E? So how far is the distance? Each grid unit represents 5 meters. Well, that's important. So it's going by 5s. Heads are not on the desk. Heads are not on the desk. There we go. So they've given you the equation. I won't give it to you. They've found the ordered pairs to these points. So the ordered pair to E appears to be So E has an ordered pair of what, 30? And negative 15. And then D has an ordered pair of, it looks like it's what, 20, is it 20? Oh yeah, because it's right there. So it's 20, and then 20, right? 20, 20. And so they've just thrown it in there. So you need to justify the steps next to it. So this is your distance formula. Then all they've done is plugged in their values. So they said that this is x sub 2. So that's y sub 2. So this must be x sub 1 and y sub 1. So then this is substitution. And then here is just simplifying. So we're going to find this out to its exact answer. So we're going to find factor 1325. What do you know using your divisibility rules that goes into that big number like 1325? Higher than 5. 25. Anytime you have a number that ends in a quarter value, double zeros, 25, 50, or 75, you know that 25 goes in there. And it just speeds up the division process. So 25 doesn't go into 13, but it goes into 132. How many quarters are in $1.32? 5 quarters, right? So that's $1.25. What's left over? 7. So 25 goes into 75 3 times. What kind of number is 53? Prime. So that means that we have a 5, a 5, and a 53. Can't I take out a pair of 5s? So really, this simplifies to 5 radical 53. But if we were to take our handy-dandy calculator, all right, so know your calculator. Gotta get the glare off of my calculator. So I'm going to take the square root of 1325. And they want you to go to the nearest tenth. So 36 point, what? What are you going to round it to? Is it a 4? Is it a 5? Is it a 40? Okay, so the nearest 10 has 1 0, so it's 1 decimal place. There's a 0 next to the 4, so it stays a 4. If it's a 5 or higher next door, that's when you bump up. And why is a decimal reasonable in this particular situation versus the 5 rad 53? I'm going to see in 5 rad 53 miles. Or meters, or whatever that happens to be. It must be meters. Yeah, it's more realistic. You have no. If I say I'm going to see you in 5 radical 53 meters, you're going to be going, what? Right? Whereas 36.4 meters might be a little bit more realistic to you, although here, do we really have an idea of what 36 meters is in this country? Because we usually use long distances in terms of miles. So miles would seem more reasonable to you. Obviously, that's not 36 miles. Right? A mile is much longer than a meter. We can get into that discussion another day. All right, so I'm going to give you an ordered pair, and I want you to find the distance for the following. So you've got endpoint A is at 3, negative 5, and endpoint B is at negative 4, negative 4. So you decide what's point A, or I'm sorry, what's point 1 and what's point 2. It doesn't matter which one is which. You throw it into the distance formula, and you come up with a simplified radical answer. when you get an answer, share it with those around you, at least 2 people around you. Share, share, share. Talk, talk, talk. If you have differences, everybody should have the same answer. So if you're different, discuss why. Gordy and Meshach, what did we get? Did you get your answer? Are you wrong too, Meshach? Did you not do it?
No, I'm on like the third step.
Okay. Where are you at? What do you have the square root of what?
I'm half a square root of 5 square root of 50.
Okay. You're good then. So this is your answer, isn't it? Now you might not have put your numbers in the same place as I did, right? But no matter what order you put these numbers in, here you should have had a 7 or a -7. And then here you should have had a 1 or a -1. Either way, it doesn't matter. When you square them, everybody should have ended up with a 49 plus 1 in there. Bless you. And then square root of 50 can be reduced. So 50 is divisible by 2 and 25 is 5 and 5. So I can take a pair of 5s out in front as a 5, and that 2 stays underneath. So the simplified radical is 5 right 2. So that should be a review, yes? Okay. So then tonight's homework, you've got another set, which I've listed on the board. So you'll finish whatever you didn't finish last night and then complete tonight's.